Hi, my name is Alan West. I'm a professor of chemical engineering and a professor of earth and environmental engineering. Our research focuses on electrochemical engineering. What we do is accelerate the adoption of electrochemical technologies. As an example, we may be very interested in developing mathematical models of batteries. And an example we show here are some SEM pictures of NMC, where we may be very interested in characterizing and modeling transport processes, as well as reaction and failure mechanisms in such materials. We also work towards the creation of electrochemical processes that may lead to the cleaner production of certain materials and chemicals. We do this by a combination of theory, modeling, and simulation, as well as experiments. In the theory area, we develop continuum level models. So we're typically doing physics-based models describing transport and reactions in complex materials. And we increasingly are taking advances from the data sciences and using those to improve our ability to describe the processes within battery systems. In the experimental area, we will often be doing experiments that are required for the model development. Sometimes they're done to validate the models, but we also do experimental work for the creation of these very novel electrochemical processes. We're also very interested in reaction mechanisms. And so we often think about what is the killer experiment that will tell us exactly why a cathode material fails in a battery. So the last question that we address in this slide is, who cares? And 5 years ago, I probably would have told you that we do this because it's very cool research, students like it, it's a great thing to get a PhD on. All that's still true. But now the whole world cares about batteries. People on Wall Street care about them because the market for batteries is going to grow by a factor of 50 to 100 in the next couple decades. The rest of society cares about them because electrochemical technologies are really key to decarbonization, and decarbonization is a key to climate change mitigation. And so, to give you an example of what I mean by this, to mitigate climate change, the society needs to move away from fossil fuels and for most things that we do in society to be powered by solar and wind. So we want to use solar and wind for the production of materials and chemicals. Again, electrochemistry will play a major role here. But we also need to have solar and wind to generate almost all the electricity that we use, and also for the transportation markets. And so energy storage becomes incredibly important. For electric cars, we need batteries. And for the grid, we need to have energy storage. We need to have batteries to overcome the fact that the sun does not always shine. So if we want to rely on solar or wind, we need to have strategies in place that allow us to store electricity for certain times when the sun is not shining. So I think the future is great for electrochemical technologies. I think it's a wonderful thing for chemical engineers to focus on, and I look forward to talking to you more. Thank you.